Today, we're going to unlock the secret behind one of the oldest and honestly one of the most powerful forms of clean energy on the entire planet. It sounds a little like a magic trick, right? How do you take the raw, flowing power of a river and turn it into the light that's on in your room right now? Well, it's not magic, but it is an absolute masterpiece of engineering. Yep, that's right, gravity. The very same force that keeps your feet planted firmly on the ground is the real engine behind all of hydropower. Everything we're about to see is built on this one fundamental, incredibly powerful principle. So to put gravity to work, you really just need one thing: height. Hydropower is all about capturing the potential energy that's just, well, stored in water that's held up high, basically waiting for a chance to fall. You know, in the world of hydro, engineers have a specific name for this. They call it head. And the rule is simple. The greater the head, meaning the higher the drop, the more potential energy you have to work with. This height is what creates the massive pressure needed to get the whole thing started. Okay, so we've got our stored energy all ready to go. Now, how do we actually release it and turn it into electricity? Let's follow the water as it takes a journey right through the heart of the plant, a place called the powerhouse. Think of this as our map for the whole operation. This diagram shows the exact path the water takes, see? From that high reservoir on the left, plunging down through all the machinery, and then flowing right back out on the right. The whole thing really boils down to three main steps. First, that high-pressure water gets funneled down a giant pipe they call a penstock. Second, the incredible force of that water spins the blades of a turbine. And third, that spinning motion gets passed right along to a generator. It's a beautifully simple and seriously powerful chain reaction. And the scale of these components is just staggering. On the left, you've got the diagram, showing how the little veins guide the water. But on the right, whoa, that's the real deal. These aren't just machine parts. They are enormous, precision-engineered giants built to handle just unimaginable forces. You know, if you can picture a kid's pinwheel spinning in the wind, you already get the basic idea of a turbine. Now, just imagine that pinwheel is being pushed not by a gentle breeze, but by the focused, immense pressure of millions of gallons of water. They're designed to be incredibly efficient too, often over 80%, to capture as much of that raw energy as possible. So we've successfully turned potential energy into mechanical spinning energy. Now it's time for the final transformation, turning that spin into the electricity that powers our lives. This is where the generator comes in. This incredible machine takes all that rotational power from the turbine and performs the final, absolutely critical conversion into electrical energy. It's really the exact same idea as that little light on a bicycle that turns on when you start pedaling. The spinning motion creates a magnetic field, and that generates an electric current. A hydrogenerator is just doing that same thing on a scale big enough to power an entire city. So we've seen the how, but why? Why go to all this trouble? Why build these massive structures in the first place? Let's zoom out for a second and take a look at the big picture. Well, here's the most important reason. Hydropower is a renewable, green energy source. Unlike fossil fuels, the process of making electricity with water doesn't produce any harmful emissions or greenhouse gases. The fuel, the water, is just returned to the river, all powered by the natural water cycle. But of course, there is a trade-off. It's not a perfect solution. On the one hand, you get all this amazing, clean, emission-free power. But on the other hand, these plants require massive infrastructure. We're talking huge dams and reservoirs, which can dramatically change landscapes and really impact local ecosystems. So after this whole journey from the reservoir all the way to the grid, what's the single most important idea you should take away from all this? It's this. Hydropower is an elegant and incredibly powerful solution. It takes a simple, natural force, gravity acting on water, and, through some really brilliant engineering, converts it into clean, reliable, and renewable electricity for millions and millions of people. And that leaves us with a really fascinating question to think about, doesn't it? Humans have been harnessing the power of water for centuries. So as we look to the future, what natural forces are we going to master next to power our world cleanly and sustainably? Hey, if you enjoyed this breakdown, make sure to subscribe to Energy Simply Explained for more deep dives into the forces that power our world. Thanks for watching.